Welcome to some Science Academy classes, and in this video we are about to start with the law of conservation of momentum. This might have been deleted from the syllabus in 2025. So what is law of conservation of momentum? Before we do that, we know that momentum is the quantity of motion contained in a body, and it's denoted by P, and it's measured as the product of mass. So law of conservation of momentum says that, let's say, uh, when two or more bodies they act upon each other, total momentum remains conserved. So that is law of conservation of momentum. So we can say that when it's just two, we will also to try to prove it, the law of conservation of momentum. So when two or more bodies they exert force on each other, or they act upon each other, they exert force on each other, total momentum remains conserved. We will try to it as well. So total momentum remains conserved, that is, and provided here the condition should be no external force. So no external force is acting on the system of two bodies. So two or more bodies. So when two or more bodies they exert or act upon each other, total momentum remains conserved, provided no external force acts on the bodies. So when no external force acts on the bodies, it means it's an isolated system. So we can write it as well. It can be written in another way for isolated system. Isolated system means when no external force is acting on a system of bodies, whether it may be two or more than two. For an isolated system, total momentum remains conserved. Okay, let's try to prove it as well, how the total momentum of the two bodies or the system of two or more bodies remains conserved. Let's say there are two objects A and B. So we are about to derive the law of conservation of momentum. So we have these two bodies. Let's say this is object A and this is object B. Okay, and they interact with each other. Let's say they collide with each other. So this is the system before collision, and let's say mass of this body is m1, mass of object B is m2, and it's moving towards the B with initial velocity u1, and it's moving towards A with initial velocity u2. So here this is the situation before collision, and now let's say these two bodies collide. So now the collision, because they are moving towards each other, so these two bodies will collide, and A will exert force on B and B will exert force on A. Let's say these bodies they collide for an instant, and after collision they will during collision they will object on A will apply force on B and B will apply force on A. So what will happen after collision? So after collision they will move either away from each other or may get deflected in a particular direction. So let's say after collision, their velocity will change. Okay, now this object E, they collide and are deflected back. So this moves with final velocity v1 and this moves with final velocity v2. Their mass remains same. So this is the situation after collision. Okay, let's try to calculate the forces. Now Let's say the force on object A, force on object A. We know that the force is given by mass into acceleration. So after collision, let's say this, it moves with acceleration a1 and this moves with acceleration a2. So the force on object A will be m1 into a1. Okay, now the acceleration. We know that acceleration is the change in velocity. So for object A, its final velocity is v1 and initial velocity is u1 by t. Okay, now let's calculate the force on object B. Force on object B will be F is equal to m2 into a2, which will be given by m2 into this will be v2 minus u. Okay, this is the force on object B. Let's say this is force on object A by B. Force on object B by A. Okay, according to Newton's third law of motion, action and reaction are equal and opposite. So we are going to use the Newton's third law of motion. And according to Newton's third law of motion, action and reaction are equal and opposite. For opposite, we put in the negative sign. Let's now write down the two forces. So this is m1 is v1 minus u1 by 2 is equal to m2 into v2 minus u2 by t. So t and t gets cancelled. And let's open up the bracket. So this is m1 v1 minus m1 u1 is m2 v2 plus this is m2 u2. Okay, now let's get these v1, the final velocity on one side. So this is m2 v2 and this is now m1 u1. So I'm moving this to this side and this to the right hand side. So m1 u1 plus m2 u2. Now this m1 v1 is the final momentum of object 1 and this is the final momentum of object 2. So this is the final momentum of the system A and B. So since the final momentum of two objects, we can write, so this is the final momentum of two objects and this is the final momentum. Sorry, this is the initial momentum because we have this is the initial momentum of the first object, this is the initial momentum of the second object. So this is the initial momentum of two objects. So final momentum of two objects is equal to the initial momentum of two objects. That is what exactly is the law of conservation of momentum. So we can say that momentum is neither created nor destroyed, but it remains conserved. So momentum is neither created nor destroyed, but remains conserved. So that we have also proved it. So this is the law of conservation of momentum. Do like, share, and subscribe. Thank you for watching.